Good morning, everyone. I'd like to thank the organizing committee for this opportunity to present our work and to say that I have no financial conflicts to disclose. So although sexual transmission of HIV accounts for the majority of infections worldwide, HIV infection among persons who inject drugs remains a public health concern. Globally, there are nearly 2 million persons who inject drugs living with HIV. And in the United States, approximately 10% of new HIV diagnoses occur within this population. Over the last 10 years, increasing abuse of opioids has led to increases in the numbers of persons who inject drugs and has been associated with regional HIV outbreaks in the US. As a prevention strategy, daily oral pre-exposure prophylaxis has been recommended for persons who inject drugs since 2013, but PrEP uptake remains low and is seen with other at-risk populations requires high levels of user adherence to achieve high levels of efficacy. As such, development of long-acting HIV prevention modalities may be particularly well suited for PrEP among persons who inject drugs by helping overcome population-specific barriers that limit PrEP uptake and adherence. Passive immunization using broadly neutralizing antibodies against HIV as long-acting PrEP is one such approach that's currently being evaluated for efficacy against sexually acquired HIV infection among men who have sex with men and women in the AMP trials. And many other bNAbs, which exhibit either greater potency or breadth of neutralization as compared to VRC01, are in clinical development. The two bNAbs used in this study, which are highlighted in the right panel, were 3BNC117, which, like VRC01, targets the CD4 binding site on GP120, and 101074, which targets a non-overlapping epitope on the V3 loop and surrounding glycans. Both of these bNAbs, as well as FC mutant derivatives of them, which have been engineered to improve half-life in vivo, have been shown to be safe and well-tolerated in a large and growing number of clinical studies. We and others have conducted preclinical non-human primate studies of these bNAbs to evaluate their protection against different mucosal routes of Shiv acquisition. The current study was performed to assess their protection against intravenous Shiv infection. For this study, macaques were given a single injection of bNAbs 1 week before the start of Shiv challenges, then were challenged repeatedly once per week until they became systemically infected, as determined by positive plasma viral load assay. Proportions of uninfected macaques were compared between treatment and control groups using the log rank test. Plasma bNAb concentrations were determined by TZMBL neutralization assays using selectively sensitive pseudoviruses to discriminate between the two bNAbs. And anti-drug antibody responses, that is, rhesus antibody responses elicited against either bNAb, were determined via ELISA using the bNAbs as coding antigens. So our design included two groups of cynomolgus macaques. The first group was comprised of 5 animals that received both bNAbs at 10 milligrams each per kilogram, whereas the control group was comprised of 2 animals that were untreated. The bNAbs used here were fully human IgG1s that did not contain any half-life modifying mutations. As you can see in the right panel, both control animals became infected following a single intravenous exposure, whereas animals that received bNAbs exhibited significant protection against a median of 5 Shiv challenges, with protection ranging from 4 to 9 challenges. With regard to early Shiv replication kinetics, we did not observe any statistically significant differences between groups for either peak viral RNA levels or viral RNA area under the curve values through 11 weeks post-infection. As for bNAb pharmacokinetics, we observed the highest levels of both bNAbs at 1 week following injection, which was the earliest time point assayed. 101074 reached an average concentration of 28 micrograms per mil and exhibited steady decline with a half-life of approximately 9 days. In contrast, 3BNC117 reached levels that were less than 10% those of 101074 and exhibited a relatively more rapid clearance from circulation. This was due in part to the generation of ADA responses against 3BNC117 in a subset of macaques. In the right panel, responses against either 3BNC117 or 101074 are shown in black or red, respectively. The time of each animal's Shiv breakthrough is denoted with a circle. So we can see, for example, that 2 different animals generated ADA responses against 3BNC117 by 3 weeks following bNAb injection, and that this corresponded to a loss of 3BNC117 neutralization activity from the plasma. At the time of Shiv breakthrough, the median concentration of 101074 in plasma was 1 microgram per mil and ranged from 0.6 to 1.6 micrograms per mil, whereas 3BNC117 was undetectable and had been for several weeks prior to breakthrough among all the treated animals. Therefore, we concluded that the observed protection was mediated by 101074, and we then used probit regression modeling shown on the right to estimate per challenge Shiv infection probability as a function of imputed 101074 plasma concentration. Among control animals, the per challenge infection probability is 100% and is shown as the blue circle with its 95% confidence interval. Tick marks in red or green represent Shiv challenge events that either did or did not result in infection, respectively. The solid black line is the model-based prediction, and the dashed lines denote 90% point-wise confidence intervals. So from this, we can see that a 99% reduction in infection probabilities compared to controls from 100% to 1% corresponded to a plasma concentration of 6.6 micrograms per mil for 101074. This slide summarizes the protective levels of 101074 that were estimated by probit regression to be associated with reductions in per challenge Shiv infection probability to 1% across several different Shiv challenge routes in different macaque studies. Those protective levels with their 95% confidence intervals are shown in the second column, and additional model details are given in the remainder of the table. We can see that very similar levels of 101074 in the range of 1 to 3 micrograms per mil were required to protect against mucosal challenge via vaginal, penile, or rectal routes, and that only modestly higher levels were needed to protect against IV challenge. While there are model-specific differences to consider when comparing these numbers, the results show collectively that across all models, 101074 concentrations below 10 micrograms per mil were associated with significant levels of protection against Shiv infection via all of the major routes of HIV infection. So to put this in translational context, plasma 101074 concentrations of at least 10 micrograms per mil were found to persist for at least 12 weeks following either a single dose of 101074 at 10 mg per kg when given alone or when given in combination with 3BNC117 in unaffected volunteers. So to summarize, a single subcutaneous injection of 101074 and 3BNC117 protected macaques against repeated intravenous Shiv challenges for up to 9 weeks. Protection in this model was attributable to 101074, which persisted relatively longer than 3BNC117 in vivo. Probit regression estimated a plasma 101074 concentration of 6.6 micrograms per mil, corresponded to 99% reduction of per challenge infection risk. And this level was modestly higher than levels found to be protective against mucosal Shiv infection via penile, vaginal, or rectal routes in related macaque challenge models. If directly translatable, these results suggest that protection against all significant routes of HIV infection could be achieved with a minimum bNAb dosing frequency of once every 3 months. Our findings, as such, extend prior observations and support the continued development of 101074 as a long-acting prevention for men, women, and persons who inject drugs. Finally, I would like to acknowledge all the people from the laboratory branch of CDC's Division of HIV/AIDS Prevention who have contributed to this study, as well as our collaborators, Mike Seaman for neutralization assays, Michelle Nussenzweig for providing bNAbs, Mel Martin for providing the infectious molecular clone for the challenge virus, and Martha Nason for regression modeling. And thank you for listening, and I'd be happy to take any questions.